Greetings all. This is part 2 of your binomial theorem formula notes. So if you look on the second part of the second page, you'll see this crazy looking sigma notation that says a plus b to the n is the sum as r goes from 0 to n of this funny thing which is not a fraction. This is known as the combination of n select r, or a binomial. It's also known as the binomial coefficient. Then you have a to the n minus r, b to the r. So let's just look at the a to the n minus r, b to the r part. This basically says I start out, for example, let's say that in this case r equals, or n equals 3. Okay, so if we, this would become then the sum from r equals 0 to 3 of 3 select r, a to the 3 minus r, b to the r. What I want to emphasize here is r is what changes as we go from term to term. N is a fixed quantity. So basically it's saying the first term would be a to the 3 minus 0, b to the 0, with some number in front of it. And we're going to talk about what this part means. Then the second term would be a squared b to the first, when you put a 1 in there. And the third term would be a to the first b squared. And then when you put a 3 in there, it would be a to the 0, b to the third. So this part right here shows what happens with a and b as you go from term to term in the sequence. This part right here tells you the coefficient from the Pascal's triangle. So we're going to look in a little more depth about what this part means by looking over to the right here on your worksheet. And this worksheet is organized slightly differently than the one I handed out in class, so kind of bear with me on that. You may have to, I probably have written things a little bit differently, but it covers the same material. Also, you can ignore the part here where it says nope in the textbook, since you don't have a textbook anymore. So here's the formula. N select r can also be written as n capital CR, which is what you might remember as a combination in probability theory from algebra 2. And the way you calculate it, that is n factorial over n minus r factorial. So for example, if I wanted to do 5 select 2, that would be the combination of 5 select 2, and then this would be 5 factorial in the numerator, 5 minus 2, or 3 factorial times 2 factorial in the denominator. Factorial just means 5 times 4 times 3 times 2 times 1, 3 times 2 times 1, 2 times 1. The 3 times 2 times 1 cancel out. You end up with 20 over 2, which is 10. So if you go back to your Pascal's triangle, this would be the third number in the row that starts 1, 5. So if we go back, let's just look back here for a minute. So when we see this is when n is 5, the third row here, notice the coefficient is, or the third entry I should say, notice that the coefficient is 10. Because you start out with n, r being 0, then r is 1, then r is 2. So you're saying 5 is your n, and you're on term 2, because it would be like term 0, 1, 2, 3, 4, 5 is the way you count up. So that's the way that part of the formula works. And let me scroll up here again. Now, this was the same theory we used. How many ways are there to choose 2 letters out of a group of 5? So you have 5 letters here. You could have AB, you could have BC, you could have CD, you could have DE. That's probably not a really good way to organize that. Let me start over. Sorry about that. You could have AB, AC, AD, AE. So that's the combination of A with all of the other letters. Now I've already done A. BA and AB are the same thing. It doesn't matter what order you put them in for this. So I'm going to start with B. So I could have BC, BD, BE. So now I've done all the ones that have B in them. So now I'm going to just go with CD, CE, and then DE. So altogether there's 10 different ways to get 2 out of 5. So that's what 2 select 5 means, but it also happens to be the binomial coefficient when you expand a binomial. So it's kind of a multi-purpose little number here. And this is what gives us the coefficients in the Pascal's triangle. So let's look at a group of 4. So just to remind you, on Pascal's triangle, 1, 1, 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. So we're talking about this row of Pascal's triangle. We start out with n is 4, and we start out with r in our little formula up here being 0. So we're looking at what happens if r is 0, 1, 2, 3, or 4. Those would be our r values. So this is r right here. So let's just think about, if I had 4 letters, how many different ways could I select 0 letters out of 4? There's only one way to select 0 letters out of 4, because you don't select any letters. Okay? How many ways is there to select 1 letter out of a group of 4? Well, I could do A, B, C, D. So there would be 4 ways. So I'm going to write here that this equals 1, this equals 4. How many ways are there to select 2 out of 4? A, B, A, C, A, D, B, C, B, D, C, D. 6. There's 6 ways to select 4 or 2 out of 4. How many ways are there to select 3 out of 4? Well, you can have it basically selecting 3 out of 4 is not selecting one of them. So there's 4 ways to not select one of them. Does that make sense? It's going to be the same numbers over here. Instead of looking at what I'm selecting, I kind of look at what I'm not selecting. There's 4 different ways to not. In one way I would exclude A, then I would exclude B, exclude C, exclude D. And so there would also be 4 ways to select 3 out of 4. There's one way to select 4 out of 4, which is just A, B, C, D. And that's 1. So that also corresponds to the opposite of 0 out of 4. So in this way, I don't select any of them. Here I select all of them. So there's the 1, 4, 6, 4, 1. If we use the factorial rule, we could also see, for example, that this would be 4 factorial over 4 minus 0, 4 factorial, 0 factorial. Ooh, important thing to tell you. 0 factorial is defined to be 1, not 0. Otherwise, I'd be dividing by 0, and that would be undefined. So that just gives me 4 factorial over 4 factorial, which is 1. If we go to the opposite end over to number 4 here, this would be 4 factorial over 0 factorial, 4 factorial, using our little formula. Also 1. Let's go back to 1. 4 factorial over 4 minus 1 factorial, which is 3 factorial, and 1 factorial. Well, if I do 4 times 3 times 2 times 1 in the numerator, and 3 times 2 times 1 in the denominator, everything cancels out except the 4. So let's see if I can find a little corner to write that. 4 times 3 times 2 times 1 over 3 times 2 times 1 times 1. All of that cancels out, and I just get 4. Okay. 6 would be 4 factorial over 4 minus 2, which is 2 factorial, 2 factorial. So 4 times 3 times 2 times 1 over 2 times 1, 2 times 1. You can see that the 4 in the numerator would cancel out with the 2 2's in the denominator. You'd be left over with 3 times 2 times 1 in the numerator, which is 6. This 3 turns out to be just the same as 4, only with the denominator switched around again. So I want you to see multiple ways of looking at the same pattern. You can count possibilities. You can look at the pattern. But that's where this thing comes from. This is called the binomial coefficient, or a combination of 4 select of n select r, whatever those numbers are. Okay, so let's take a look at applying the binomial formula to a couple of examples. So using the binomial formula, I know here that n is equal to 6, a is equal to 2x cubed, and b is equal to negative y. Notice that's the example we did at the end of the previous section of notes. So we already know what the third term is. As a matter of fact, let's go back up and look so we can say this is what we're looking for, is this one right here, the third term. Okay, so 240x to the 12th y squared. So that's what I'm looking for. Now, using the formula, I can say 2x cubed minus y to the 6th is equal to the sum of r equals 0 to 6 of 6 select r, a to the, okay, I know what a is, so let me go ahead and put a is. So a is, oh shoot, I didn't mean to erase, 2x cubed to the 6 minus r and negative y to the r. Now if I want the third term, what does that mean r equals? It's not 3, because you start counting where? You start counting with 0. 0, 1, 2. So r is equal to 2. So putting 2 into this gives me 6 select 2, 2x to the, 2x to the third, to the fourth, negative y squared. Well, notice here's our x to the 12th y squared, which we were looking for. If we go back up to that one we circled, where is it? There it is. There's our x to the 12th y squared. So how do we get the 240? Well, 6 select 2 is 6 factorial over 6 minus 2, 4 factorial, 2 factorial. This ends up being 16x to the 12th when you and this ends up being y squared. Okay, so we've got that part. So we just need to figure out the 6 factorial part, and I'm running out of room, so I'm kind of running down. Please hang on just a second. I need to pause. Okay, I need to gather my thoughts again. Someone came to the door and I had to stop. So here we are. We need to evaluate the factorial. Now, you can say, hey, you know, I can do all this stuff on my calculator. I don't really need to do this by hand. But yes, you do, because I want to see that you know what everything means. So I want you to do this by hand with some simple examples. So we're going to say 6 factorial, 6 times, not 2, 6 times 5 times 4 times 3 times 2 times 1. And this is 4 times 3 times 2 times 1 times 2 times 1. Then I can just cancel out everything 4 and below. I also know then that this is 30 over 2, so this becomes 15. So now I know that I have 15 times 16x the 12th times y squared. So all I have to do is multiply 15 times 16. When I multiply 15 times 16, I get 240 x the 12th y squared. Now, would I want to do this for every term? Heavens, no. This would take forever. So why do I want you to do this? I want you to understand what the binomial theorem is telling you. I want you to be able to interpret a more complicated looking sigma notation and understand how to use it and all of those things. So I will only ask you to find a single term. The trickiest part for most students is remembering that if I asked for the third term that r isn't 3, it's 2. So be careful about that. So let's do one more. What I think I'll do here is, once again, why don't you try this, pause it, and then come back and I'll talk quickly through. So I'm going to go ahead and pause it, write down the answer, and then come back and talk about it. Okay, back again. Let's first identify our n, our a, our b, and our r. N is 18, a is 3x, b is negative 4y, r is 11. Using our summation notation, n, we'd put 18 in every place there's an n. We'd put 3x for a, we'd put negative 4y for b. And we could actually go directly to this, putting 11 in for r as well. So you should end up with this line. Now I just wanted to show you a kind of a little shortcut when you see the 18 and the 11 here and the 7 and the 11 here. 18 select 11 is 18 factorial over 7 factorial, 11 factorial. Notice that the two numbers in the denominator match these two exponents. That will always be true. Cool, huh? 3x to the 7th. So that's going to be 3 to the 7th. I'm just going to write this, kind of spread this. 3 to the 7th times x to the 7th times negative 4y to the 11th. Notice that's going to be a negative number times y, or negative 4 to the 11th, y to the 11th. So my coefficient is going to consist of this big number here times 3 to the 7th times negative 4 to the 11th. It is going to be an extremely large number. So let me just show you a nifty tip here. 18, it would be 18 times 17 times 16 times 15 times 14 times 13 times 12 times 11 factorial. I don't have to write the rest of it because I know anything below 11 is going to get canceled out with the other 11 factorial. 5 times 4 times 3 times 2 times 1. So 11, those are going to cancel out. Now I go through and I see, okay, a 12, that's going to cancel out with the 3 and the 4. 14, the 2 and the 7. 5 goes into 15 3 times. 6 goes into 18 3 times. So what I'm left with is 3 times 17 times 16 times 3. All right, so I'm just looking at these four numbers to multiply together. Now, can you do the whole factorial thing in your calculator? Definitely. But if I say write it out and show me how this formula works, I want you to be able to do it. So this is what I'm showing you, some tips. Oh, wait a minute. Half point opportunity missed you. Many of you are going, wait a minute, there's a 13 over there, you forgot. It's here. Sorry, got to do that too. Realize this is going to be a huge number. So when you multiply all that stuff left over in the numerator times 3 to the 7th times negative 4 to the 11th, you're going to end up with this. Negative 2.919 dot 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 times 10 to the 14th times x to the 7th y to the 11th. So this coefficient, huge number here. And so I probably won't give you one that big on the test. Just, you know, we're not going for messy here. I just want you to understand the concepts. So on your we'll do on the calculator, if you go to probability under your menu, go to probability. Let's see, I should probably get this out and double check. Probability, and I don't remember. I think I'll pause here and check this out. Okay, here it is. If you go to menu, probability, combinations, something will pop up that looks like this, NCR, with and then a parentheses, and what you're going to put in is the N, comma, and then the R. So if you do 18 here and 11 here, then you'll get the number that you would get this number here. So that's how you can do it on the calculator, but be able to do it by hand if I asked you to. So that's all. Well, no, I'm sorry. I just wanted to show you one other page. This was not something we did in class, but it's included in the PDF of the notes online. And this is Understanding the Binomial Theorem. I think I'm just going to open this up. Basically, it takes a whole example, if you're curious how the binomial theorem really works. So it breaks down the formula. I'm using an example when n is 4. It shows you how we calculate, basically how we expand this out. So if I go from 0, when I start with r equals 0, r equals 1, 2, 3, and 4, plug it into the formula, then we'd have 4 select 0, a to the 4th, b to the 0. 4 select 1, a to the 3rd, b to the 1st. 4 select 2, a squared, b squared. 4 select 3, a to the 1st, b to the 3rd. 4 select 4, a to the 0, b to the 0, and so forth. I kind of showed you the different ways how this 4 select 0, 4 select 1, 4 select 2 works with these different groups of things, and basically how you get that line in the triangle that we did, and explain a little bit more about this. Then how would this apply to multiplying out a binomial? So if you actually numbered this as a sub 1, b sub 1, a sub 2, b sub 2, and so forth, and you multiplied this out, it turns out, how many ways are there to get an a to the 4th? Well, you'd have to multiply a to the 1st, a to the 2nd, a to the 3rd, a to the 4th to get a to the 4th. How many ways are there to get a to the 3rd b? Well, there are, if I multiplied the 3 a's from the first one times the b in the last one, that would be a to the 1st, a to the 2nd, a to the 3rd, b to the 4th. Or I could use the first 2 a's and the 4th a and the 3rd b, and so forth. So there's 4 different ways to get an a cubed b by using these 4 terms. There's 6 different ways to get an a squared b squared. 4 ways to get ab cubed and 1 way to get a b to the 4th. So this is why these binomial coefficients actually work when we multiply out a binomial. And the last page of the notes that are on the PDF just show you a color-coded example showing all the patterns. So if you're just interested in kind of understanding better why the whole binomial theorem works and how it relates to the Pascal's triangle, this color-coded example I think will help you kind of think through that process. So if you, I hope this is helpful as you've gone through this if you didn't quite understand what we did in class.